Hey everyone, today we're going to look at random samples and what does that actually mean. So when we go and collect data and we're studying it or we're looking at a group of people, the entire group that is studied is known as the population. Okay, so and I put the population over here in the big circle too. So while a sample, so let me write sample. A sample is a selected group from this population. Let me got it here. Okay, so we're going to look at sample and population today and what those mean for you. And if you'll write sample over here in the smaller circle. So a random sample is a selected group from the population that we have. And we're looking at, here we go. All right. Oh, and okay. So anyway, a random sample is a selected group from the population that is chosen randomly, where every member of the population has an equal chance of being selected. And this goal is to accurately represent that population that it's chosen from. So what does that all mean? Okay. Let's go to the next part and get an example. So when you were in elementary school and your teachers wanted to randomly call out a name, they probably had a popsicle stick. And so those popsicle sticks had everyone's name on it. They were probably in a jar and they chose one of them. Okay. And you were like, oh my gosh, let it be me, or don't let it be me if you didn't know what in the world was going on. But it gave everyone an equal chance, right? Because the entire class's names were in there. So a non-example of this would be maybe only the boys' names, and then they chose one or two out of that with only using the boys' names from that class. So the reason it is a non-example is because you've selected already a small group instead of having everyone an equal chance. And so that's why it's a non-example. Okay. The big thing about random samples, it has to be equal for everyone. So on this example, we're going to use some objects, and we're going to use colored tiles to represent t-shirts. Okay. So we're going to go ahead and fill in all of this information into, I'm just going to write it in, I think. Let me use blue. Into here. So in green, there are 23. In blue, there are 32 shirts or tiles. Orange is 17. And 28 in red. Let me try and change that to an 8. 28 in red. Alrighty, so if you add these together, you should get 100 shirts. All right. And so now we want to look at the right in the percentage. So if our total of tiles is 100, then our percentage is exactly the same. We don't have to do anything to it or multiply or anything like we're going to need to in these next examples. So if you'll put 23% to 32% and so on. All right, so I went ahead and filled in the rest of the table, and that's what it should be. It's really hard for me to draw a percent sign apparently. But all right, so we have 100% total. Now it looks like this. If Joseph pulls the following 10 tiles from the bag, so he's only pulling 10 from the bag, we know that we're going to have 10 tally marks. So let's look. Green, there's 1 green, 2 greens. So you can write 2 tallies if you want. You could write, and because that kind of looks like an 11. So that's just write a 2. But we are looking at tally marks. So blue, there's 1 blue here, 2, and that looks like it. There's 1 more. 3. Orange, 1, 2, only 2 oranges, and reds. Here's 1, there's 1, there's 1, there's 3. Okay. So if we're looking, we have a total of 10 tiles. Now we know we want to get to 100%. Okay. And if I want 100%, 10 times what will get me to 100? So we want to multiply by 10 to get to 100. So each one of these tiles, the green, the blue, orange, and red, is going to be multiplied by 10. So really I have 20% green and 30% blue, and the same for orange, 20%. And red has 30%. And if I add them all up, I should get 100%. Okay. Now, the last little thing said, did the random sample reflect the population well? So did it look like what we thought we were going to have way up here? And yes, if you look at green, it's 23%, and that's really pretty close to our 20% with our 10 tiles. Same here for blue with 30, really close to the 32 we had with 100, and so on. Okay, 17 and 20, 28 and 30. So if we do another example, so we're going to look at this data here. We're going to have vegetables, and they already gave us how many baskets we have for each vegetable. So I'm going to fill in here. I'm not going to write down the whole word because that would make your video really long, but that's tomatoes is 1 through 11. Potatoes would be 12 through 14. Okra, and we're going to set it as 25 through 31. And then 32 through 50 are the squash. Okay. So again, you can get the words from right over here. I didn't want to write them all to take up forever. Okay, so if you notice, we have a total of 50. This is why we went to 50 right here. If you add all of these guys together basket-wise, okay? Now, we know, again, we want to get to 100%. So 50 times what gets you to 100? So you're going to multiply by 2. So each one of these will be multiplied by 2, okay? Okay, so I went ahead and filled in the table by multiplying by 2 to each one of these. If I added these all up, it would give me 100%. So let's look at part B of this. So part B, Mario randomly generates a list of 20 numbers, and he gets this following list. So what we're going to do is look at what we had on that last little slide. Using this information, where would they fall under tomatoes, potatoes, okra, and squash? So you have it on your paper. So tomatoes, I'm going to look at how many are underneath 1 through 11. So 1, 2, 3, 4. So there's going to be 4 tomatoes. Potatoes are a range of 12 to 24. So I have these. So I get 5 potatoes. Okra is a range from 25 to 31. And I get 3 okra. And then the squash are what's left. So there are 8 of them. If we had a total, we already said earlier and we underlined it, there's 20 numbers. So we again want to get to 100%. So 20 times what gets you to 100%? And it's times 5. So 4 times 5, 5 times 5, 3 times 5, and 8 times 5. And be sure to go back and put your percent signs. Alrighty, so I went back and I put my percent signs in. So did the random sample reflect the population well? If we went back and looked at tomatoes and we have 20%, all right, our tomatoes in our 11 baskets was at 22. Yes, it does reflect the population well. Just like on the last one, the other one represented the population well as well. So that is it for today. Be sure that you're looking at, is your thing totally equal to everyone? So if you're going to survey a population, okay, take a look. Am I surveying everyone that has a possibility? Make sure you're not only looking at the boys, because that doesn't have an equal chance for everyone. All right. And if you have questions, contact Miss Hill or myself.